And good afternoon, or good evening, or maybe even good morning, everyone who is watching the stream of AD Rives on Air, and welcome to my another 3D modeling stream. So a little bit of live preview, but then we'll switch to the modeling software, sorry. So what's going on? This is part 2. Part 1 happened quite some time ago. You can find it on my YouTube channel, so, and still probably on Twitch. So I bought a ton, well, not a ton, actually exactly 8 of these cells of a relatively new format called 32140 or 33140. So what does it mean? 32 or 33 millimeters in diameter, 140 millimeters in length. So cylindrical, lithium iron polymer batteries. I think I'm kind of pronouncing it right in English. It's like LiFePO4. Would it be in like its chemical formula? So what about them? They're very cool. Each one can offer you quite some current for discharge at 3.2 volts of voltage. Max is 0.37, 365, 3.65, and this is 15 ampere hours. Not pitnats, not in Russian. 15, so 15 ampere hours. So pretty capable things. So a battery like this that I wanted to have for myself is going to offer me no less than 12 volts and 30 ampere hours on 12 volts. And it's actually, it's heavy, but it's not that heavy. It's not lead battery, acid lead battery, of course. So, but because of course you could just take these batteries and just bind them together using some sort of tape, but I'm not that type of person. I wanted to have a holder for them, and I wanted to have them in a very specific containment where I just want them to be there inside that box, where they would just serve their purpose of working as a UPS for low voltage devices like routers, like I don't know, USB chargers and whatnot, things like that. Even though modern USB chargers actually can, they are still low voltage, but they can actually consume quite some current. So, and we have already designed a couple holders. So the standard holders that you can buy everywhere, they are like this. They are modular, so 2 pieces in one. So, but using this one, I couldn't fit them where I needed them. So I designed this holder, even with a cap. So it actually goes like inside absolutely beautifully, like stays there almost like so, even with a cap, which is a total overkill. Nobody really does it, but I kind of decided to go with it. I mean, it's sort of kind of I don't know, sort of kind of an investment in hope that these things, according to all the specifications, they support to work for a very long time. So these are not lead acid, these are not your standard lithium batteries. These are the next generation, more advanced ones. So that's what's written on them. You can probably read it. So that's pretty much what they are. And I wanted to have a holder for them just because, well, they are so good, deserve kind of good holder. So we have designed 2 types, this type last time and this type, and I got them printed, and we learned a lot from this. I learned a lot from this. As you can see, I designed the caps too, but because of these elements, they won't be, because the way I designed it all. So these are not just holders, they can be put on and removed with the batteries already connected to each other. So that's the thing. That's the difference between even these holders and my holders. You can see the pattern here, the connections here, and you still can remove it. So, but because it kind of leaves quite some stuff exposed, yeah, I designed the caps. So I designed 2 types, this type, and this type. The first thing, the experiment, the first thing that was useful, that was a result of these prints, is that this is the right design for the place. This is not the right design. It's not going to fit, though the idea is pretty cool. So, but this one's not going to fit. So these go away. Now, that was expected. I expected things to not really fit in the box I wanted this assembly to be in. I expected it. So we can shrink it down a little bit, and we need just a little bit. As you can see, there's quite some room between the batteries, especially if you look at it like from the side. The gaps are pretty serious, so we can shrink them down. We will end up with some very thin walls here, but that's okay. I think that that's okay, considering we are going to have the outer cap that's that'll give us the music is a little bit too loud on Twitch. Let me make it a little bit quieter. So considering that there's going to be a cap holding additionally everything together. Yeah, okay. So you can see it actually here, how my design is a little bit more superior. Okay, I don't want them to jump out, but they are all, yeah, okay. Okay, they are all falling out. Cool. Come on. Come on, go in. So that's another problem, but let's get to it. So see, that's my design. So they're going to be connected. They are not oriented properly right now. The orientation is random. So they're going to be connected like this and like this, which is the right way. But the thing is that when you connect them, when you actually weld them together, you can do it just like this. And here we go. If you need to work on the assembly, you can disassemble the assembly. But so I expected that this might not fit. I expected that I'd have to shrink it down. Okay. And then a couple of other problems. That's gonna be one of them is gonna be harder to explain. First of all, the diameter of the slots for them. So it really depends on the type of the thingy we're designing, we're printing. So if it's like this, if it has gaps, it goes in pretty easily. So no problem here. But if it's like this, you start having some serious problems. They just don't really want to fit. It's too tight. So here they would go normally because there's a gap and this is more relaxed. This is just bends a little bit naturally, and this is way less relaxed. So either we just make them all a little bit larger here, or we make only the ones that are not going to have any gaps a little bit larger slots for the batteries. Because yeah, I tried to force them in and I ended up damaging the insulation on one of the batteries, unfortunately. So they are not like all new and shiny. They are not new and shiny anymore. So that's one thing. And another thing, that in case of this design, so this is like, for example, top, like let's treat it like a car battery. So we have the terminals on the top. So this is like bottom, this is like top. So this position of the terminals is not right. I mean, they has to be, I think, here and here. Yeah, they has to be here and here. So the terminals look like this because it's going to be a nickel tape, pretty much metal tape that you weld onto it. So, and it would go like this, and then under the cap it would go outside. So there is just 0.25 millimeter here, so you can fit the cap. If you cannot, you can just do a little bit of filing here, and you'd be able to fit the cap on with the terminal, that nickel tape going out of here, going out from under the cap. So while the idea is right, the execution ended up being a problem. So, but we learned from our mistakes, and now we are going to design better ones. So I'm thinking, of course, first of all, making two different sizes for these slots. It's going to be complicated, but it's going to be doable. So what we can do, we can color code them, and when we have like a slot without any gaps, then it's going to be a little bit larger, 3375, I think. When it has a slot like this one, it's going to be a little bit smaller, 33.5, because again, for those who just missed, perfectly fits, pretty snug, not tight, just snug, but here it gets a little bit too tight, and the tolerances on this like shrink tube they are in, it's like they are actually pretty different in terms of this this insulation on them. Some are a little bit like it's like parts of millimeter, but still, so it's technically actually pretty small difference between them. But when it comes to 3D printing, it's a difference between just the element getting stuck inside this slot, not going in and not going out, and the element just going in and going out pretty easily, any of them with any side of it. So this side is like fraction of a millimeter thicker than this side because it's plus. So yeah, we learned a couple things, and we got to fix them. But the most annoying part, the most kind of stupidest part, was that I designed the terminals to be in the completely wrong places. So as you can see, if we have connections here, we have connections here, then the terminals, they cannot be here, they have to be where it all ends. So here and here, so here and here. So because the battery, let me actually show it to you using these two batteries as to create a mock-up. Because the battery, are you going in, or something is in the way? Oh yeah, this one's already a little bit damaged here. I'm damaging them kinda a lot. So here's a mock-up. Imagine there's all 8 of them. Yeah, look at the gap between them. So that's quite some room for making this gap way smaller, and that will allow us to shrink the whole assembly a little bit. We need just a little bit. Plus we can do some tricks, shaving off these edges completely, so leaving only the cap, this cap, to hold them together. So, but imagine this is like all 8 batteries here. I'm not going to put all 8 in because it's impossible, almost impossible, without damaging them, to remove them from the slots. So that's the way the battery is going to be oriented in the device. So so it would be way actually smarter, since we're gonna need to have this and this here. What did I just think? I thought about reorienting them. Yeah, I thought about reorienting them completely. So even changing this design too. So we will get to that. But because the battery is going to be oriented like this, it would be way smarter to have the terminals, and it's possible to do it, to come out here and here, to have just the board, the BMS board for them sitting here. So because they're gonna have like a BMS board, and because the connection to the charger to the load is going to be here. So that's how it's going to be. The connections here, the boards here, everything kind of like this. Yeah. So what are the constraints, where we have the limits? So lengthwise is okay, it's okay. This tall, I guess, not tall. White wise is okay, all white, length, whatever. So in this dimension, it's completely okay. We have enough room. In this dimension, we are completely okay, enough room. In vertical dimension, in this dimension here, we are not okay. We need to shave a little bit off. That's what we are that's what we gonna be doing. So let's just start working on it, I guess. So let's clean this up, but not completely because I might need it. So this is like the caps. Why do I, these are connected ones. So okay, so let's move this out of the way. I'm gonna be working in the same pretty much space, adding more to its complexity, but why not? So oops, move you out of the way. So these are the caps. Yeah, we are not going to need them too. So the caps in my code, they are of this color. And these are the main hexagons. The basic primitives the assembly starts with. So from these hexagons, I'm only going to use its height. So they are like 20 millimeters. So we gotta try to make them smaller. How to decide how small we might need them? So this is pretty much the battery. And yeah, 33 and 5. 33 and 5. Yeah, this we don't need. This is an old one. The small one, not tall one. So this is the cut for the contact pad of the battery for the terminal. So let's see, let's start experimenting with hexagons. So it's like just about manually adjusting them, picking one size, and then just going with it. So first of all, one's gonna be 33 and 5. One's gonna have the hole for 33 and 5. That's gonna be annoying. 33 and 5 for the ones that are that have cuts in them, like these ones here. These are 33 and 5. And the ones without cuts, like this one here, they're going to be 33.75. Freaking annoying that's going to be to have two sizes, but that's what the perfection requires from us. Well, nobody's going to see it though, but I still want to do it properly. So first of all, let's change the color of this to make it something completely different. So I kind of remember what revisions I have where. So this we will probably delete. This is like the old very first experiments. And this is what I designed on the last stream. I actually wanted to kind of brag a little bit. So complex shapes I can create using just basic shapes like cylinders and cubes and hexagons. So it's cool. So here we have the small diameter. Let's make it the large diameter. 33 and 75. Let's make it. So this is our diameter for the cell holder, for the holder without any gaps in them. So let's center it inside the hexagon. Like this. So now it's centered and it's large. The small one we always can do. Unfortunately, there are no color for the holes. I wish they were. So this is the large hole. Got to remember that this is the large one. So the large one, let's make them like of this color. The large ones. Wait a second. Do we use red? No, we are not using red. Let's make them red-ish. So this is the large one. The large ones. And the small ones with the smaller hole in them going to be the greenish ones. Now let's find the size for hexagon that we can use for this. So hexagons are a little bit more tricky because they are not squares. So to move them proportionally, to like change them proportionally and not like this, you gotta do it like this. So they stay of the same size in terms of their sides stay the same size like this. So okay, for example, let's make it like this. So let's see, for example, we make it like this. It's too small maybe, but let's see how small that is. We are just working here, just trying to eye it out. So you go here, you go here. Okay, these are like very thin walls. So the old hexagon was the new hexagon 3975 by 3442. The new hexagon, yeah, that's the size of it, and that's the size of the old one, 4175, 36, 34. So we shaved off 2 millimeters immediately in the dimension that we technically, well, I mean, in any of the dimensions. Let's put it that way, 4175, and here 3975. Here we have 3616, and here we have 3442. So we can try to go even deeper. That'll create probably the walls too thin for the printer to print, but that's not a big deal. We just need to not go outside of these walls. But I think if we use this size, which is okay, I guess, and then we shave a little bit off. So let's actually see just the experiment. So we take, for example, this model here, and what I'm talking when I mean shaving, We take this, we make it like this, we move it like this, make it larger, make it larger, I said. So move it a little bit in and do it like this. Didn't work. Oops. And do it like this. Why not working? So this is union, not a bundle. Okay, this, union. Yep. So as you can see, we shaved off the edges of it. So which is kinda, I think, acceptable in this case. And I think just by the section, we got a little bit of couple millimeters off. So that's what I'm going to do. So plus it creates this kind of planes here on which the assembly is going to be, well, kind of leaning onto, not line, because line is going to be line. Oh no, actually it depends on, it's going to be line on these ones. Yeah, so these ones are just sticking out. So though creating the right shape of the cap for this is going to be another difficulty, another problem, but yeah. So let's start working on it. So that was just experiment to see how the shaving would just work. Okay, so here we have one for the big for the cell holder with a big hole in it. This we move out of the way. This I think we move like completely out of the way. I'll maybe delete it later. So okay, this size that we got here looks completely legit. Still the sides seem to be they're supposed to be equal, so we are not creating any problems for ourselves. Let's see, let's start working on it. So starting from these primitives, so one's like this, 2 millimeters from the bottom. Let's do the cut. So this is the red one. The red one means, just checking it again, the larger hole for the cell. Here we go. So we got the first one. Now we need to make a hole in it for the terminal, for the pad. No, redo. Align L. Got to learn the hotkeys. Okay. And union. So this is our holder, basic element of the holder that's not going to have any cuts in it. No gaps, no cuts. So the hole in it is a little bit larger because of it. So I think yeah, it's going to be used as is. So this one is going to be green one, light green. So this one is going to have, wait a second, before changing anything, yes, like this. This one is going to be smaller one, going to have a smaller hole. So this hole is going to be 33 and 50. Do not forget to realign it, to center it. Like this. So create a copy of it. So these ones are going to be going to have cuts in them, gaps for the metal. Is it tape? Is it called tape? What connects them? What you use to weld them together? I think it's called tape. So instead of wires, you use just a metal tape to connect them, because it's weldable. Wires are hardly weldable, but the tape is. So cut the hole. Here we go. Take this one, move it in here, then align it, and cut the hole too. Okay, that's the element, the basic element. So here we go. We got this going. All the basic elements are created. Now we just got to assemble the whole assembly from the basic elements. Let's get back to the camera. So now the part that's harder to explain. So I'm just going to use this as a battery holder. So that's the only way for me to keep them in place while just moving them back and forth. So yeah, unfortunately, see how the pattern, oh god, that's like, see what, see how the pattern of connecting them goes. So like this, and then like this, two in parallel connecting to another two in parallel, then on the other side there's a connection between these two on the other side, and then two in parallel connect two in parallel, so all connected, like it's like 4 in series, 2 in parallel, for S to P. The battery, the assembly type is called for S to P. But I kind of want to propose another pattern of connecting them. 2 in parallel, 2 in parallel, 2 in parallel, 2 in parallel. Then on the other side it jumps to this one, and then 2 in parallel and 2 in parallel, and we get the terminals on the other side. They would be on this and on this one. So again, 2 in parallel, 2 in parallel, 2 in parallel, 2 in parallel, on the other side connecting to 2 in parallel, 2 in parallel, and the terminals underneath, and I can just direct them pretty much like here. So the terminals will just go here. That's where I need them for the BMS, for the board, balancing board. So which is sort of kind of that's what we got to try. So let's start working on that assembly. Let's start working on that type of assembly. So these ones are larger ones, these ones are smaller ones. So the smaller ones we need to use for cutting. So let's start working on them, on cutting them and assembling them into into the shape we need them to be in. So basically, let's just copy a bunch of them, just so like this, then 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 like this. Not that I need it right now, sorry, not that I need it right now, but it's just I lost one. So connections going to be like here, here, here. Then the connection on the other side happens to this one. Pum, 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 pum. And then connection goes here, here, and here. So let's start designing the elements we need for these connections and the challenges we might encounter here. So on this side, we are not going to use a single red one because they're all going to be somehow connected. So for this one, we need just one cut. And the cuts, I do it like this. I take this, and move it here. So then I move it roughly like this in here. Then we align it. Like this. And then we cut it. So here we have one. It has to be turned, so we'll turn it, but let's make a copy of this one. So this has to be turned, not 45, but 30 degrees, like this. The next one is going to be one that looks at this one like this. So 150 minus 150. So, but the connection from this one, I'm looking at it in the wrong way. Oh crap, I'm not showing it to you. I was like designing things, not showing it to you. Apologies. So let me take a look here. Not the right placement of the element. Got to turn this one a little bit more. Has to be 30 degrees more, like this. Then this one goes here and it gets turned a little bit more, minus 30, like this. And then the other element is going to be here like this. So this one then needs a cut in here. right. Right. It needs a cut in here. For that, we got to turn it back a little bit. 30 degrees to be able to make a perfect cut. So I'm going to use the same cutting element, cutting template for all of them. So that's for 15 millimeter wide tape. And this goes like here, and then aligns to this one like this, and then we cut it. And then we cut it. So there's an element here, a free floating, but it's not going to be free floating in the model. So this goes here. Oops, do not do that. That will just destroy pretty much everything. So you do not change the size of it. So you make it like this. Yeah, roughly for now. So then here we are going to need an element that will take this connection coming from this side. So minus 120. It will take connection coming from this side like this and sends it further down. It would send it further down. That's easy to do. We just move this here, align, and make this cut. Here we go. Again, we got some free floating elements, but since not a single one of them is going to be used separately, all these free floating elements are going to be together. Going to be just one thing, one way or another. Yeah, they got to be on the same level. That's crucial. So I'm not moving them vertically in here, only left and right, up and down. Okay. And then for the other element of the assembly, it is going to be this here. So that's our two pairs, one pair and another pair connected. Swov, good evening, welcome. Not the rocket science, just basic, very basic battery rechargeable battery holder design. So I'm pretty much working on where's that, yeah. Instead of this stuff you can buy pretty much anywhere for the batteries to hold them together in the assembly like this. So instead of this stuff, that's not going to fit where I need it. For me, it's not going to work. I'm designing my own. Like. So this is part 2, by the way. This is part 2. The part 1 happened quite some time ago. Oops. These batteries are still heavy, so don't want to just throw them down. So okay, this path we have designed. Now let's continue with the other parts of it. So these are like 2 in parallel, serial, 2 in parallel. Now another serial connection happens on the other side that we keep in mind, that we just imagine that. So this we need to be like this then. That's where another connection starts. Yep. It goes then here and here. So we take this element then and rotate it. Did I take the right one? Yeah, I took the right one. Minus 60. So hexagonal symmetry here, it's not like a scene in this software. So then we're gonna need a new type that we do not have. So let's make that type we do not have. Minus 60. Yep. We take the cutting template, move it here. Align it. And make a new shape. Here we go. So this shape goes here. And then the last shape is just this one. So this feels like a way better idea than the previous one. But that's an... oh, crap. I wasn't showing it again. God. So, apologies for showing my hands instead of just 3D modeling. So, but that's what we got to. I'm having lots of issues today with like switching scenes in OBS. So, my bad. Please tell me if I'm showing the wrong scene to you. So here we have one side of the holder roughly thrown together. So let's make it a solid thing. So let's just take this the way it is and copy it. This we don't need. The cutting block, just going to leave it in here. So first of all, I mean, let's start with this assembly, I suppose. Doesn't matter which one, which side we start with. So we take this one, for example. Let's move it a little bit out of the way. This one, let's align them together like this one. They're already aligned. Are they really? Yeah, because it's all pretty much is snapping to the grid. Okay, I'm just trying to get to the max level of magnification that'll give us ability to kind of weld things together in this program. So, and to weld them together, like for any software to think that this is just one shape, one object, but not two, we do it like this. This is the smallest precision. So the smallest amount of movement we can have in this program, I think, in Tinkercad. So that's like fraction of a millimeter, but that's pretty much sort of kind of uses them all together. So when you join them, like, let me show you like this. yeah, when you join them like this, see, there's no seam here. No gaps, no seams. So otherwise, unfortunately, that's how Tinkercad works, and I didn't find a way to get around this. Haven't yet. So otherwise, there's like a seam, which I don't like. Okay, now you take this. You take this, you align it like this, and then you move it in. And then you zoom in to the max. So this movement, it's like 0.1 of millimeter, so 1/10 of a millimeter. I think what we are doing here is maybe 200ths or 100ths of a millimeter. So the smallest amount of motion we can have in this program. Okay, now a little bit tricky part to do the same stuff with an angled, to create an angled join like here. We just need to rotate this one a little bit, like this, for example, 60 degrees, and that becomes pretty much not angled. And this we rotate to 60 degrees, and now we can join it pretty easily. Align this one like this, and then we again join them. So, oops, I think I'm moving both of the, no, I'm not moving anything. Oh boy, I thought I was moving something. I was still in the aligning mode. So the deepest magnification like this. So here we go. Now we take this, go out of the way. We take this assembly and rotate it back 60 degrees. That's just the easiest way to understand. So now we need to align this one here, to attach this one here. So let's again align it like this, then move it in. Oops, not like this, like this. And then this is 1 millimeter of overlap, I think. So you can see that we have quite some steps in this 1 millimeter. Okay, here we go. Now we need to turn this again 30 degrees. And take what? Oops. I made a mistake, I think. No, I didn't make a mistake. Everything's right. So can you please give me the part? Oops. So minus 30, like this. You then go here, align, move in, then move in, and then move in even more. Yep. Okay. So a little bit of an overlap. And the way we are working with these overlaps is that they are so tiny, though they are so small, that no printer would be able to see the difference. No printer would be able to like print out the difference, but the software would just treat this all like one big shape. Let's actually check it. Union. Here we go. As you can see, no seams here. So undid that. 30 degrees, please. And here we just keep going with the alignment. You align to this one like this. Then you move in like this. Then we magnify to the deepest level. And we just leave a little bit of an overlap. So that creates a little bit of an overlap everywhere here. It might be slightly uneven. So be it. So be it. It's not a big problem. So because the difference is going to be a microscopic fraction of a millimeter. As far as I understand, let's just check. So here is a little bit more, here is a little bit less. Well, I mean, it's microscopic. I think it's not like 1/100th of a millimeter, it's a little bit more than that, but it's definitely at least 3 times smaller than 1/10th of a millimeter. I hope it just... I'm not making a huge mistake here with these approximations. Okay, this is like this is 1 millimeter overlap. As you can see, it is absolutely gigantic. So this is the smallest overlap possible. Okay, we got the first one assembled. Let's just, this we don't need anymore. No, we need it. We don't. Let's move it out of the way for now. So this one, yeah, technically we don't need this one. I don't want to have a ton of copies of the same, only the copies I need. So this is now this becomes just one shape for now, just to see if, yeah, no visible seams, everything looks cool. So the idea is that like 2 terminals of the same polarity, then jump to another 2 terminals of the opposite polarity, then on the other side jump to this element of different polarity, then 2 of different polarity, then jump to like 2 more of the different polarity. So boom, 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 boom. Right. Only one connection is going to be on the other side. This is like the bottom side, as I keep calling it. So the bottom side of the holder. Let's start working on the top side, which is going to be a little bit more interesting. So for that, we got to be looking at this one too. And we got to be looking at it. I cannot even turn things properly 180 degrees. Yeah, like this. So we're gonna be looking at it as our sort of kind of reference for the connections we need to make on the top side. The top side's going to be a little bit harder, because it's going to consist from the different elements here. So this is going to be the first one, and the first one is going to be actually, it's going to have an output for the terminal of the whole battery. So let's cut the hole in it. Yeah, maybe even let's do it like this. Yeah, we definitely got to turn it upside down. Like this. Yeah. And this aligns to this element like this. And to make a clean cut, we do it like this. So the first element is here. It's gonna be looking like this, 120. So then 1, 2, no connections. So we take this one. Yeah, I got to turn it upside down, all of them. Like this. So we attach this one to this one. Let's attach them. First align them like this. Then you go in. Cannot even see the smallest overlap without magnifying going really deep with magnification. So then the third element, just like this one, we do the same. Magnifying to the gap and close the gap like this. So of course, the way I'm joining them, I just probably do not know something about this software. This is an online, absolutely free software available in your browser. So maybe I don't know something about how to just join things in this program. More advanced ones, the ones that you probably do not use in your, well, I mean, there are a ton of browser ones. More advanced ones probably have tools for at least joining planes, fusing planes together. Okay, here we got to take this one, because this one's going to be our first connection and the only connection on the top side. It's gonna be like this. So, and we align it to any of these three. So let's just move them 30 degrees. This one 30 degrees. And then we just do this. You and you're gonna be together from now on. Yeah, this level of magnification is even pretty tricky in this program, so it doesn't really work that well. Okay, minus 30. So yeah, now we need, I shouldn't have done that. Now we need the one that's gonna be answering to that connection. So that's 180. Then goes here, then aligns, and then joins. Like this. So, and that's the only connection on the top that we have here. So now let's just start throwing the ones we need to have in here. This one we need to have in here. So let's align it to this one then, because why not? They're supposed to be the same. They're not probably like 100% the same, but the precision is enough for our goals here. So these ones, are they joined? Are they fused together now? Yeah, they are. Okay. And then turn it back to more normal state, like this. Like this. And add the ones and finish up just assembling it. You go here, you align like this. There's a micro gap. No micro gap. And then the last one. Yeah. No. Wait. This one connects like this. No, not like this. Turn, turn, turn. Then jumps on this side. That's this connection here. It's this one. Dun, 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 and then goes, well, I mean, sorta, kinda, yeah. I think I'm not making another topological mistake with orienting these batteries. like this. Align like this. Yeah. I made actually two big mistakes here. That I what yeah. So the difference in color, it's not for the top or the bottom. The difference is color. The color difference in them, it's like the size of the cutout for the battery. So the ones that don't have any gaps, they have larger cutout for the battery. The ones with gaps, they have smaller cutout. So these are supposed to be the green ones. Okay, I'm stupid. So this and this we remove. The green ones are supposed to be here. Oh boy. Okay. So because naturally when you have such a big gap here, such a big cut, the hole for the battery can be a little bit microscopically tighter. So, oops, what did I do? I just clicked something and something happened. Yeah, it's hard to actually stay at the deepest level of magnification. Okay, like this. So the same one has to be here. Just looking. Oops. Minus. Minus 120. Yep. Here we go. Move it out a little bit. And then the smallest gap, smallest overlap I can create. Okay. And now for the connection we need here. One 20. Like this. Alignment again. Aligned. And then the smallest overlap. Like this one. And then the one for this situation, 180. Okay. So there's a bunch of ways to align this one, but let's use the easiest way. Here you can see there's a gap. We just minimize this gap. So here we go. So this is the bottom and this is the top. So the holders technically are ready. So the only thing we need now is to send them to be printed. Yeah, gonna have problems like here. It's too thin. Not a big deal. Can live with that. But to make them a little bit stronger, because this part here, it has a ton of gaps in here, literally a ton. So of course it has to be printed with higher density. I don't have a printer. I order printing, so I can just request this to be printed with higher density. So but on top of it being printed with higher density, I kinda design caps for them. So that's a little bit harder. And plus it's going to be another level of hardness if we decide to do some shaving. If we decide to cut off these sides here. So let's see what we can actually do in terms of doing that, in terms of cutting things off to make them smaller in this direction. So union, okay, whatever. 180. So let's see. I like align to anything. Can we make it align to anything? I'm curious, can we make it snap to anything? This complex shape. Well, yeah, actually. So yeah, it seems like we managed to snap this corner to the grid. So we can now try to cut off the exact amount of millimeters here. And let's see how it works. And how to design a cap for that. So this is cutting off 1 millimeter, this is cutting off 2 millimeters. So let's see what it looks like. It looks like this. Technically speaking, not bad. But we'll have to create custom shapes if we want to have the holder for the cap for this holder. How do we do that? Well, the same way we've done it before. First, we got to create the dummy holder without any cuts or holes in it. I think that's what we're going to need. A dummy holder without any cuts or holes in it, yeah. So Then this goes away. So these are, oops, do not do that. So technically the holder is ready. The rest, what we're doing right now, designing a cap for it, it's like pretty much cherry on top. Big cherry, very big cherry, but still a cherry on top. So let's do exactly that. Let's try to do it. It might not really work. It might not look good, but at least if we can put it on, so then yeah. So the thing about the dummy, just give me a second. The thing about the dummy thing for the cap, actually I removed this one, how I made it, yeah, my bad. They have to be larger ones on the of the dummy assembly, larger elements, larger hexagons, just slightly larger ones, centered around actually the real assembly, centered around every hexagon of the real assembly. So we're going to need the real assembly, not unionized, like this. So, and what we do, we align them to each other. So like this. But this hexagon, let's make it of a little bit different color, has to be a little bit a microscopic amount or larger than the one inside. Pretty much just a bit larger. Let's see what the difference we can create. What difference we can create. First, we create the dummy assembly, just like this one, but consisting of hexagons without any cutouts that are just a tad larger. Why did you become tall? Why did you become tall? Because it becomes like that in all dimensions. Yeah, I see now. That's the thing. 1904. Yeah, I've created a little problem for myself that I forgot about. So yeah, they are not 20 millimeters. They are all 1904 now. That's not a big deal. They can be of any height. The height just got to be a little bit more than, I think, 15 millimeters. So okay then. 19 though, this is annoying. Do I need to like redo everything because of its 19? Do I need, let me think about it, because I just forgot about this size. Well, I can redo everything, because if I just go and change their size like like this, it'll change this size here, which is not a big deal. It's gonna change only a slightest amount, so probably can leave with that. It's not going to be 2 millimeters, it's going to be 2 something millimeters then. Is it going to become a problem if the thickness of this part becomes just a little bit more? Let me think if it kind of carries any complications. Technically, in this dimension, we are not limited in any way in the length of the assembly. If the walls here become just a tad thicker, well, I mean, just to have it like 100% proper, I could just redo everything. But this time it's going to take actually way less time. So okay, let's make it all again, because I forgot about the proper height of the element. My bad. So you go away. These ones, they go away too. We start again. 3375, 3250, 3350. Yeah, right. So that's the problem. It has to be 20, not 1904. That's the right height of it. And then this one, 20. Now they are of the right size. So you go here, become a union. You go here, become a union too. Now this. Okay, annoying, but well, I mean, we made a small mistake that I don't mind spending some time on correcting. Cut, you, align. Yeah. Before cutting, make a copy. Like this. Before unionizing, make a copy. So, because I know how to go back in time, how to undo for the whole project, but I cannot undo things for, I don't know how, maybe there's no way, for separate elements of the project. Then union this. Here we go. Now we have two proper ones. The red one is the red one has larger hole for the battery. The green one has smaller hole for the battery. So we got to make now what we did here, but using the proper elements. So let's start working on it. Turn this upside down. 180. Can I have 180, please? Yes, thank you. So you Like this, centered, centered. So this is the first element. So only the green ones are supposed to be cut. Oh, sorry, I don't need this help. Only the green ones are supposed to be cut like this. The red ones are not supposed to be cut in any way. Okay. Oops. Like this. Then like this. Then align. Then cut. Another element's ready. Then we need then we're gonna need a couple more elements here. All derived from this one. $60, please. Like this. Realign. Like this. And then cut. Like this. Another element's ready. Like for this. Yeah, right. For this element. And then we're gonna need one more. One more building block. Four building blocks in total here. Yeah, 4 building blocks in total. This one. Oops, do not do that. That's just destroys. That will destroy everything. Oops, I lost the cutting a rectangle or cutting block. Oops, I changed the shape, the size of it. You accidentally change the size of some important shapes, and in this program I think you might be like super done. If you don't notice it, you won't be able to just, you'll be basing your design on some elements of wrong size if you don't notice how you change the size of them. Here we go. This one's done. Okay, now we need to assemble this shape here. Let's start doing exactly that. So the first element is this one, and we turn it -60. The second element is gonna be this one, and we turn it 60. And then the third element, well, I mean, let's join these two first. Alignment, microscopic overlap, and then this element is going to be this one. Minus 120. Go in here, get aligned. Like this. A little bit too much of the overlap, of course. Let's fuse them together properly. Just a fraction of a millimeter. Okay, so we're pretty much reassembling this, but from the elements of the more right size. More right, it's like arbitrary here. But still. So this we turn 30. Then take this one. Oops, do not do that. Turn this one 32. And align it. Fuse it with this one. Align it to it first and then fuse. Like this, like this. Oops, I don't need settings. Oops, they seem to be not aligned. How is it even possible? They seem to be creating a step here. Huh. See, there's a small one. It's microscopic. It's not going to change really anything, but it's not supposed to be there, I believe. I think I made a small mistake somewhere. Microscopic. Maybe not that microscopic. Churchy, good evening, welcome. Yeah, kinda doing super basic stuff here. Are you not aligned to something? Are you smaller for some reason? Okay, let's see if we can realign it. Maybe I made a small... No, it thinks it's aligned. Okay, then. So, yeah, I'm kind of working on custom holders for these elements, for these batteries here. Explained it in the beginning, and this is a part 2. So we already got some prints out here. We already got some prints, but they're not going to work. So I don't have a 3D printer. I ordered the prints. I model myself, but I do not print. So, and these ones, they are just a little bit too big. That's the first thing that was expected. And the other thing that I made a mistake in just, well, pretty much in the design. One mistake is that these holes, they are not big enough for these batteries. It's like too tight. I don't want it to be too tight. It's because of the gaps here. So when there's a gap, it makes the hole a little bit larger, or it makes the hole to be able to stretch a little bit. So it stretches and the battery goes in like pretty easy. But when there's no gap, it's solid circle. Yeah, it's hard to fit it in there. I already damaged some insulations on these ones. So yeah, no need technically for these custom holders technically, but for this project I could just tape the batteries all together using just a painter's tape or something, but I want it to be solid. Sort of kind of learning things. This is going to be my like first super big assembly, so it's going to be 12 volt 30 ampere hour battery. I have a bunch of these elements here, so it's going to be pretty big one, and I want to do it like as right as I can. So did we fuse this one in properly? Yeah, so this is definitely less than 100ths of a millimeter, I think, because this is like 2 or 3 hundredths of a millimeter, so this is even less. But yeah, I'd really love to have a 3D printer, Churchy, but no room for that. Simply, I live in a small apartment. My small apartment, the overall square footage, square footage in square meters is like 60.2 overall, discounting everything. So there's simply not enough room for another desk, for a workbench, for a 3D printer, unfortunately. So now we take another element, that's this one, move it here, align it to this one. I'm using super basic, like child level program Tinkercad, but actually even in Tinkercad you can do a lot. It's free. It's actually by Autodesk, I think, so it's free, but even in this one you can do a lot. If you just, you start with basic shapes, and then you start you start using like interactions between them like this, and you might end up with pretty complex shapes this way. So but of course what I'm doing right now, probably in some more professional, yeah, this is not right. This is like not right, really. Something feels a little bit wrong. Maybe because the hexagons are of a little bit different shape. Maybe the sides of them are not 100% equal. But okay, it's all microscopic differences. No 3D printer again would be able to print that, print the difference, see the difference. So let's just see if it kind of works together properly. Yeah, so what I'm trying to do here is like no seams, at least here. Interesting that we got the seam gone here, but not here, not here. So some seams go away, some don't, because, well, yeah, of the way how we create it. So then we're gonna need this element, and to align it properly we'll have to do it like this, then turn the whole assembly. Oops. Turn the whole assembly -30, and then attach it here. like this. I like doing that. It's kind of a pretty advanced Minecraft. Long time ago, when I first saw a first 3D modeling software, the first version of 3D Studio, it was like, back then it wasn't 3D Max. I think, is it still called 3D Max? Back then it was 3D Studio. So I was fascinated by that stuff, really. So I wanted to learn, and I learned pretty much. I started learning how to work in it, how to do things in it. And this reminds me really of that. Not 35, 30. Of my first experiments in 3D Studio with very basic shapes. So, pretty much. That was like 1994, 1995. I didn't have a PC back then, so it was at my stepfather's work. And one day I'll forget to align them, and I'll end up with a huge difference. But so far, I kind of remember about that. So far, I've been remembering about that. Come on. The magnification is a little bit hard for these levels of magnification. And the last one. The last one's going to be this one. Just 180. Goes here. This we move out of the way. You align like this, and then we join them. What did I move? Did I move anything? No, that's our alignment. I didn't move anything. Okay. So the bottom's ready. The bottom, instead of this one, I've redone it in the right size. So, and to avoid any freaking confusion here, we remove this one. That's not the right size. And we just take this one and move it here. So the difference between this one, this is 20 and this is 1904. Not even, which is not right at all. Now let's assemble this side. This is the bottom side of the holder, and this is the top side of the holder. So again, for those who just joined, the color difference between the elements means the size of the hole for the battery. The red ones, they have a little bit larger holes to accommodate better for the size of the battery, because without any cutouts, like the greens ones have, without any cutouts, it's way stiffer and it's harder to push the battery in. So when you have cutouts, you can have like the socket for the battery smaller, just to make it sit there tighter, because naturally these cutouts, they create some sort of a relief. And well, the battery naturally sits there a little bit looser. Even if the same size of the cutout, the same size of the hole, the cutouts make it like the battery just sits there a little bit in a looser way. So first we need this element. Oops. Let's start with this one. Turn it 60 degrees, minus 60, like this. Then we're gonna need one of these. And then another one. Well, and then another one here. Well, yeah, we'll do it a little bit later. First, let's start with these two. Hey, what the hell's wrong with you? Okay, made a mistake here. I didn't take the right one. At least I was able to catch it. Instead of the new one that's exactly 20 millimeters tall, I took the old one, and that was our mistake, and is 1904 millimeters tall, which is like pretty uneven. Okay. And then we join you, moving you in for the smallest amount of movement. Smallest step possible in this software. Then you will do the same, like this. And that's too big. Like this. The smallest possible overlap. I heard that people use this element here, drop to the work plane. This tool here, drop to the work plane, to actually conjoin them. But mirror and join. So it would be like, well, to join them, but that would be like drop to the plane, mirror, drop to the plane, mirror, I think. And yeah, since I don't need like 1/1000th of a millimeter precision here, so to me this way is going to work, just without making mistakes. Without making mistakes, this would be easier to do. Okay. Oops. So now we need to minus 30, angle U, back to straightness, then angle U, like this, I think. Yeah, 30. Then align U to this one, like this, and then do that microscopic overlap if the magnification allows me to see it. So very microscopic. Then we turn it back to normal. 30, like this. And this piece here, everything is good. And this piece here, so I've already done it. Today I just pretty much am recreating it using the elements of the right size, and not that difference was critical. It's just I'm trying to make everything unnecessarily perfect, just because we can. Oops. Okay, that's the right, that's this one. Now we need the same element, turned 180, align to this assembly, turned -30 degrees, and you, oops, do not do that, turn -32 degrees. This way we can join you all together. Alignment. A microscopic amount of overlap. Then you go back to normal orientation, 30. And then this goes here like this. Alignment. That microscopic gap. That microscopic overlap. Yeah. If you do everything properly, everything gets overlapped properly. And then the last one is this one. You remove it like this. You stay like, stop. We turn you at 90. No, not at 90. At 120 it was. Oh, yeah, something along those lines. And then we repeat this trick again in the 8th time. Alignment, tiny overlap. Okay, so this one's ready. This one we delete to remove any possible confusion. Space Melody Lab, Nicola, good evening, welcome. Yeah, it sorta is. Actually, it's way closer to puzzles, but here you use the basic elements to build a pretty complex shapes in the end, using like the basic elements. So I'm really proud of this one, of this shape, of this here, because you start with just cylinders, hexagons, and cubes, and you end up with something like this. Very complex shape. So, okay, we got that's the bottom part of the holder, and that's the top part of the holder. They are of the right size, of the right height, 20. So now it's time to design the dummy holder for creating a cap, for creating the cap for them. So, and these ones are going to need the cap. Okay. Okay. This is going to be a little bit harder to do, because I want to do some additional, how to say it right? Some additional changes. I would like to introduce some additional changes to the shape of it to make it even smaller. So the idea is, I've designed already what I needed, but it's just, well, it has mistakes. Mistakes are easy to fix, but the main thing, this one is a little bit too big. So, and I'm making it just that smaller. We need like to remove 5 millimeters or something, not more than that. And I think I've already shaved enough, but I think shaved off enough. I think I could just shave off a little bit more, a millimeter on the side or something. So I think I can do it. So let me think how to approach this. First of all, let's take our rectangle, our hexagon, our basic hexagon, and create another hexagon of the same size. Make it of a different color, add a different color, and let's see. So we just needed we just needed a little bit larger, but the difference got to be microscopic, like this maybe. So the old one is 3975, the new one 4007. Okay, and if you just let's not forget about this. So they have to be of the same height for me to be able to see it. And let's see how they align. Like this, like this. Ooh. Yeah, the gap is microscopic. I think it should be a little bit larger. Just a little bit larger. So the green one inside is smaller, the blue one outside is larger. So let's make it one step like this, one step larger. Again, vertical size of it we have to control manually. Let me take a look. Maybe I made it a little bit too big. Okay, whatever. So this is visible, and the size between them, it's like, yeah, this is getting close to a millimeter. That's a lot. So no. You stay like this, and this looks more like maybe, probably there's a way to measure this, but I think it's close to 1/3 of a millimeter, maybe one quarter of a millimeter. So that's what we need. I think that's what we need. So let's build our dummy dummy holder for building. First you build dummy holder, then you build the cap around it, and then you use the dummy holder to cut the hole in the cap. So no, not you. So let's start building the dummy holder then. Oops. You go here. So the best way to do it would be just start aligning everything with everything. So you take this, and you align them to this one like this. You take this, you align them to this one like this. See, they are just a tad larger. That's what we need. Just a tiny tad larger. Maybe not enough for the printer to print, but this is the cap. If it doesn't fit, we always can try to redo it. This one to this one, and like this. Here we go. And keep going. Oops. Align. This one. Align. This one to this one. Align. This one to this one. Align. Oops. This one to this one. Align. Click. Align. So this is our dummy holder. So now we need to just take these ones and remove this. It is just a little bit larger than the real holder because it's dummy. It has to represent the cutout for the real holder. Okay. I think I moved a little bit fast. So let's keep it together for now. What if we do the cutting? Crap. We'll have to cut 2 different parts using the same cutting shape. So pretty much with them being in one spot. Is it going to be possible? We might end up with tolerances being a little bit too tight on places where we start actually cutting off, just shaving off things. Let me think about that. Let me think about how to prepare the dummy holder when the real holder actually doesn't have its sides shaved off yet. Good question. The only way would be to actually create the elements with properly cut sides. Otherwise, we would have to improvise a little bit. I mean, I could improvise with just a file after printing, after getting everything printed. If something doesn't fit, if the cap doesn't want to go properly on the holder, I could just use the file on the holder. And pretty much, well, do not overthink it. Or we can do it in a different way. Let's see if we can. So these assemblies we still got to move out of each other. So let's start with this one. So snap to grid, and let's see if we can snap it to anything. Yes, we can. We actually I need the whole assembly to be moved. Okay, let's just group it, bundle it. It's not one shape, it's a bundle of separate shapes. So yeah, okay. As you can see, it is properly aligned here. The other side, it's not really, but we can do that trick here. That's what we need. The only thing we need here. The only thing we need here. So let's turn it upside down. Let's turn it upside down, I said. So let's keep it aligned. Yeah, good, very good. That's what I don't need anything more than that. I just need exactly this. Let's create our cutting shape. Wait, are you 20? Yes, you are 23 already. Okay. Now you're touching. And if I do it like this, that's gonna cut 2 millimeters off. 2 millimeters seems a little bit like too much. Let's cut 1.5 millimeters. Yeah, like this. So let's see if I can make it work. It's gonna become one group. Yeah, Okay, but I cut these sides, which is what I actually wanted. Oh, let's turn it 180. Uh-huh. Okay. Okay. So we are making it a little bit smaller. So we're shaving off like half millimeter and a half here, millimeter and a half here. That's 3 millimeters. And again, an average, I think I needed 5. So I just compactified the whole assembly. I got, I think, several millimeters there, and from this alone I'm only getting 3 millimeters, which is kind of nice. So another hole. Okay, let's check if it's, yeah, it's aligned, and this is aligned, and then move in. Now you are aligned. 1, 2, 3. Yep, that's millimeter and a half. Is it though? Yeah, that's the millimeter and a half. You become a union. Something didn't work. You become a union. Okay. Are you symmetrical? You seem to be symmetrical. So this is like getting pretty complex. So now we have this one prepared. It's already one shape, so it's ready to be printed. Let's see if we have maybe some obvious problems or gaps here. This side, no, looks solid. So we move you out of the way then. And then we do this same cutting trick on this assembly. So this pretty much represents this. It's just microscopically larger. So become a bundle, please. Perfect, perfect. Ability to snap things to grid and move them, just staying connected to the grid is saving me here. Uh-huh. 1, 2, 3. This gets unionized with this. And we get this shape. Then we turn it the other way around. This is better to actually, I rotated it 180. It's better to rotate it back just for me to be able to see. Well, I mean, the connections are already made, but just if I do not see, I don't know, maybe if I just see it somehow in the wrong light, the wrong angle, and might start thinking that I made a mistake. So it's better to just look at it at just one angle. Okay. Yeah. The fact that I can align it and then can the same changes to the shape. It's like 1, 2, 3, and then we cut. So this now represents this. The only difference, this one is microscopically larger than the actual holder. Let's, by the way, even see it by aligning one into another. So yeah, if you look at the sides, there is supposed to be this even outline here that's even everywhere. So this is for our cap. And now to build the cap, we have to do the same trick again, just using larger hexagons. So pretty much let's take the original hexagon. No, let's not take the original hexagon. Let's take this hexagon, make it of a different color because this is going to represent the cap itself. And then use this hexagon as a guide. So let's make this one larger right away. Just like a little bit to see. So we need 2mm walls. That's, I think, kinda 2mm walls. So let's see if we can get that. Minor problem. You got to stay 20. So this is roughly 0.5mm walls. Okay, let's see. 20 back. You realign. More like it. Let's move you around a little bit. Let's move you around a little bit, I said. Like this. And if I just drop you here. So this is 1.5 millimeter thick walls. Should we make it a little bit larger even? So I know that these walls here, they have like very random, not random, but different thickness everywhere. But the only one that's consistent in here, it's this wall. So these walls here, they are supposed to be 2 millimeters. So if I can have some consistency, then let's try to have some consistency. So we're making this one again just a tad larger. Oops, not this. This and this. And alignment to this one. And this looks more like ended up, yeah, because I moved it. So this is almost 2 millimeters. Almost 2. Let's make it just one step larger. That's gonna be 2 millimeters, I think it's going to be. The blue, this one, alignment to this one. Yeah. This is almost 2 millimeters thick walls. So the walls I'm talking about, it's these ones. So that's how the cap looks. That's what the caps looks like. And that's how the holder is going to look like. This is just not the right shape and not the right cutouts. And that's how they're supposed to go together. So this is a prototype that unfortunately is not good for anything. So lost some money here, but not a lot. So yeah, that's what I'm talking about. Okay, so we got the right size of this thing, and it has to be 22 millimeters. Like this. And it has to be on the plane like this. Right. And then what we do, we assemble the cap using the holder itself as a guide. The same way we assemble the dummy holder. So you go here and align. You go here and align. You go here and align. All right. Everything's going according to the plan. You go here and align. You go here and align. You go here and align. I forgot to press the key. You go here and align. You go here and align. Okay, so we have this assembly. Oops, forgot to select this one. So this we don't need anymore. So this is our cap. Now we got to do the same thing to the cap, to this cap we did to this part and to this part. We got to shave 1.5 millimeters off of its sides. So let's do it. Create the shaving block. Make it larger just to be on the safe side vertically. Oops. Like this. Then move it in. And change this to 0.5 millimeter. 1, 2, 3. Perfect. Then unionize. 180. Rinse, repeat. The cutting block. Realign. Realigned. 0.5 millimeter. 1, 3. And 1, 2, 3. Union. Here we go. Now the moment of truth. So I should have actually kept the not. Oh, yeah, I made a couple mistakes. My bad. So you got to stay as a copy. This one had to stay as a copy too, but I forgot about it. So no copy of that one, only the element of it. And now we unionize things. Here we go. Now this side. Go down. Get close. Everything aligned to just 1 millimeter. Like this. And then 0.5 millimeter. 1, 2, 3. Unionize. Okay, we got the shape. Now the moment of truth. We take this one and we put it inside this one. So this represents our holder. This represents the cap. Like this. Align. We can do this and turn it upside down. Just because, why not? 180, 180. And then we do this. We don't do this. We take what's inside the blue union. We turn it into the hole. And then we unionize. And here we have what? We have our cap. And then just to check it, just give me a second, please. Just a second. Okay, I'm back, and the real moment of truth here. So we made the cap. As you can see, it's supposed to be roughly 2 millimeters here, and then the lid itself 2 millimeters. So pretty complex shape, as you can see. And then let's try aligning this one into this one for the test. That's for the test. That's how they going to be interacting with each other IRL. So you go 2 millimeters up like this. Perfect. Look at the gaps. They're almost, well, not 100% for some reason. Not 100% perfect for some reason. Yeah, we have a problem. So it's perfect here. But how? I think we made a mistake somewhere. There is a mistake somewhere because the gap is here. It's perfect. It's uniform. It's uniform here. And then here, it's not uniform. Huh. Interesting. Here it's uniform. Here it's uniform. One element was out of alignment. Just one. Just one element was out of alignment. But which one? Was it the element of the cap? No, it wasn't the element of the cap. It was this element. It was out of alignment. Let's take a look. So maybe just a little bit. Seems okay here. Yeah. Yeah. It's visible. See? It is out of alignment here. I don't know how that happened, but it's not aligned properly. And here. Oops, stop. It's good here. And it's good here. Just one element somehow ended up being out of alignment. Okay, we got to redo it, but otherwise, just apart from one element, we have a super uniform pretty much uniform shape here. Sorry for the background noise. There's a little bit of home keeping going on in the background. So Nicola, thank you for watching. Yeah, and you have a good one. So this goes back. This is not right then. So let's try to fix this maybe. Oh yeah, maybe we can actually fix it. The text scene. Oh, sorry, I cannot read your name. Thank you for the follow. It's a little bit too hard for me right now. I'm focused on other stuff here a little bit. Text will do. Yeah, I hope it will. So thank you for the follow. Welcome to the stream. Okay. Yeah, this is somehow out of alignment. Let's see if it's in one axis only. Yeah. It somehow ended up out of alignment only in one axis only. So I think we maybe can fix it by just doing something like this. No, we cannot. So this one is on the line. This one is not on the line. Why is it not on the line? How is it even possible? I did not align it properly. Well, that's the only explanation. Okay. Let's then do this manually then. Ah, no, wait a second. Let's not be stupid. We have them separated now. This, unbundle it, please. This one, alignment to this one. And here we go. We fixed it. Let's check if everything else, if the other elements are aligned. So it was a microscopic mistake. Probably it wouldn't have changed anything or changed very little, but I just, decided to fix it. Okay. You then stay. Even though we can access you, we can actually go back in time for you now. At least when it comes to unionizing things, it's possible to go back in time, which is nice. So, and let's do the cutting we need to do. So you got to be a bundle to be moved around easier. You got to be like here. And then we shave off 1, 2, 3. We shave off 1.5 millimeters. 1, 2, 3. You and you. Here we go. Now, same on the other side. Millimeters. Align this one. You go in like this, and then 1.5 millimeters. 1, 2, 3. 1.5 millimeters. And then shave off. Here we go. Now we take this. We take this. Put them inside each other. Then maybe turn them 180 for us to be able to see what we are doing. Then we turn this into a hole, and then we make the cut. Okay, that was another attempt at creating a cap, the cap for the assembly. Now let's test if they form a uniform gap between them. Here we go, fits nicely. 1, 2, 3, 4. That's on the same level now. And then we check the gap. And the gap seems to be uniform between the lead. We need a little bit of a gap. The printer probably won't be able to process it properly, but it'll create some sort of difference between some sort of distance between this wall and this wall here. So this is like a millimeter. No, this is like 2/3 of a millimeter, because this is like 2 millimeters. So, well, I mean, thin, but that's not a big deal because we have a cap on top of it. Okay, so technically speaking, we are done. Let's compare the sizes. So that's the old cap. That's the new one. No, we are not done. We need to do some shaving here. So this one already got its sides removed, shaved off, and this one it still has them. So let's see. I'm interested in this size. So that would be currently X. Yeah. That's gonna be Y, and that's gonna be Z. So in X plane, in X dimension. So let's see. 1 millimeter. Let's align them. And this one. Oh, it's even hard to actually figure that out. Okay. Let's put it like this. To the corner, maybe. Yeah. To the corner. Oh, yeah. You look at the difference in X size. This is like how many millimeters? Let's see. Sorta. Are we on the plane? Yes, we are on the plane. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Almost 8. I think I got it. I got to test it. Because I can take this cap, the one that's purple here. I can take it and I can try to fit it in the box. So, but I think we got it. Let me actually check it. Don't go away. I'll be back in a second. Just give me a sec. Okay, I'll be back in a sec. Just yeah, a break, a toilet break. Okay, and I'm back. So the music gets quieter. So yeah, I have a nice pink ruler here. Uh, I've checked the real size. So, and this here is represented with the purple one, this one. So, and we learned that we managed to shave off 1, 2, 3, 4, 5, 6, 7, 7 something millimeters. Okay, I measured it. So, and I learned that we actually need a couple more millimeters to be on the safe side. So, and I have an idea which is not really amazing, but it might work because a couple millimeters that we just need from here, we maybe can get just by removing completely these sides here. So the holder itself without the cap, so this, it'll fit 100%, no, not a problem. But I want to have the cap because I'm like that. And maybe we could use the fact that the cap actually has the cap itself, not just sides but the top, and that's why it doesn't really need the sides everywhere. So let's maybe cut off more even. So what I'm talking about is that we take the cap, so this is like the normal one with all the sides. We again align it properly. It's not on the plane. Now you are. So then we take another shaving block, cutting block. So this is like, okay, the thickness of the walls is a little bit more even than 2 millimeters. So technically I could maybe keep just a little bit. So this is like 2 millimeters. If it's 1.5 millimeters, 1, 2, 3. Yeah, that actually might work. I might keep the sides, though they're going to be 0.5 millimeter thick. Well, 2/3 of a millimeter thick. But this might work, and then the cap 100% will fit in a box I want it to be in. I think, yeah, I think that's what we got to do. That's what we simply got to do. So the thickness of the walls is not going to be uniform, but this is just the cap. I'm kind of building it like I'm going to use it in some moving vehicle with vibrations and maybe occasional like shocks and whatnot. But this one's going to be just on the wall. On a wall, on a shelf. So yeah, kinda a little bit thin here, but better than nothing. And let's move it let's turn it 180 and do the same operation here. I could use the same cutting block, but I keep losing them after actually cutting. One, two, three, yeah. And you cut this off. Here we go. Oddly specific shape, but yeah, okay. Now let's compare it to the old cap the same way. Not off, 1 millimeter. What am I even doing? Like this. And you go here like this. And then you both drop under the plane for me to be able to count. Yep. So, and here we have the difference. So 1, 2, 3, 4, 5, 6, 7, 8, 9. From here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's perfect. So again, the holder itself fits 100%. Just this one, the new design. And now the cap actually fits too. It might be a little bit a little bit of a strange shape, but it actually going to fit, which is super cool. So the only thing we need to do, we need to finish with this one. No, copy it. So we need to do some cutting here, like this. So we cut off 1, 2, 3 millimeter and a half. Here we go. Turn this 180. Oh, I made another stupid mistake. Good that I actually noticed it. So the problem is these shapes here, they're not supposed to be like these ones. They are supposed to be slightly different. So let's redesign them. So we take the green one. No, that's not gonna be the green one. That's gonna be this one, because no cut sides, only the top's going to be cut a little bit. So good that I cut this issue. So let's take the cutting block. So this is 20. Let's make it 22 like this. Oh, 18? No, 20. No. Whatever. 2 millimeters probably should be enough, but whatever. So 20, 20, just to be able to see it. Align like this. You go in. Okay, it's on the not on the plane. Sorry for the noise. And then we need a pretty specific cut in here. 1, 2. We need this cut. This is for the metal tape to go out. So then we turn you. Then we turn you. Then we turn you 30 degrees. No, we do not turn you 30 degrees. We turn you 60 degrees. We move you in like this. And then we align you back to the rest of the assembly. Anchoring it to this one. Like this. And then we just join them the only way I know works for sure in this software. Here we go. I caught this problem. I'm so glad I caught it. So not 44. Stop. What are you doing? Has to be 60 like this. You go here. Did I accidentally align it perfectly? Loser, nice to see. Haven't seen you in a while, man. I know that you're active on Twitter. I can see you there. Thank you for, by the way, pressing that like button sometimes. Thank you for jumping in here. Oops, I think I made it the wrong way. Thank you for jumping in. Hope everything's amazing. I'm just doing a little bit of... Okay, I don't like this. Let's make it this way. So I'm not seeing this way. I cannot see which part moves. So yeah, welcome, man. Move you a little bit out. So I'm working here, as you probably could see on Twitter, on some holders for 32/33 140 elements. So not that these holders are really needed, but I'm learning. Well, I need holders for them for a different project that's coming. This is just kinda my first big battery assembly is going to be, and I'm building it like it's going to be used on like in rough conditions, vibration, shocks, but this one's actually going to be on the wall, so doesn't need any holders at all. Eight elements of this type, so not like they're going to need any holders, but in my case this is a test bed for building a slightly larger battery, and that one's going to need some holders. So though here I'm already kind of working within the constraints of this is going to be inside the box that I already have, and I'm working within the constraints of that box. I'm trying to just fit it inside. It would and the irony is that that battery assembly would fit inside perfectly without any holders. So, but I'm making the things a little bit harder for me, for myself. So this is the bottom part of the holder with all the guides for the connections. The beauty of my design though here is that they're gonna, of course, it's gonna hold the batteries, the cells together, but when I weld them with this metal strips, metal tape, metal strips, so when I weld them together, I'll be able to remove the holders if I want to without cutting the strips between batteries. So the same's here, the same's true here. So without cutting anything. Totally removable holders. And because like the structure here is a little bit more sort of kind of fragile because it has a lot of cuts, I came up with an idea of a cap. Plus to protect, because every hole here, every like gap here, it's all metal parts of the batteries. So the ones that actually have voltage on them. So to insulate them additionally with a layer of plastic would be a good idea. Okay, we have redesigned this the way we needed it. Now let's do some shaving. Bundle this, please. Align snap to grid. That'll do. That'll do. These are the last steps of the build. Of the design. I hope I didn't forget anything. 1, 2, 3. So we are removing 1.5 millimeters of the sides like this. Ooh. Managed to have a different color in it. Looks interesting. Well, okay. You're supposed to be pink-ish of this color. So, well, or technically any color, because the color codes here, they are for slightly different holes for the batteries. So the green ones, they have cuts, so they're a little bit tighter. The pink ones, they don't have any cuts in them. They are solid, so they are a little bit looser. With Twitch and logging in with browser issues. Looser. I'm not sure what you're talking about. If it's like some recent news, then I haven't heard anything. For me, it seems to be all pretty much the same. Let me check in my second. On my second PC. On my second PC, it's not asking me to log into anything. I'm still logged. So if I miss some news, then yeah, apologies. Haven't seen any problems. Haven't noticed any problems in that relation. Okay, and another side we need to shave. Oops. Aligned. Aligned, perfectly aligned. Silly message browser not supported. I haven't seen that. That I haven't seen. But you know it's Twitch. You know it's Twitch. They come up with bugs like that almost every day. So 1, 2, 3, 1.5 millimeters to remove off of this. Here we go. Now let's check if it fits. Just last check before calling it a finished print. And back like this. That's the orientation I'm used to here. So we take this cap, just copy it. We take this, just copy it too. And then they are both on the plane, and you get aligned, centered around this one. Does it fit? It does actually fit. Though this one's supposed to be 1, 2, 3, 4, like this, inside the cap. So do we have the uniform microscopic gap between the holder and the cap? Yes, we do. We do have the uniform microscopic gap. So the printer kinda, when it comes to forming gaps of this side, the 3D printers, even like, well, not the basic, I don't know what printer is used by the guy who prints this stuff for me, but it's capable of creating the said gap. Maybe it's like just, I don't know, something that's more imaginary than real, but I already kind of done it. So this we have here, it's like not the right size, not the right design, but the idea that allowed us to test the idea. So here we go. And can you see the difference between the inside and the outside? It's like super small. Fits super nicely. It's flush here, though it's not needed. Nothing here is needed really. But yeah. That's what it looks like. Just give me a sec. I got the message. Yeah. So we are sort of done with this one, I think. So we are sort of done with this one. So we have, this is the bottom, this is the top, this is the bottom, and this is the lid. Okay. And this is all the parts I used to build this one. So I think we are actually done with this design, though it's not going to be the only design. We're gonna need more of that. We're gonna need more. We got to design more holders. So, and this is a holder for 12 volt 30 ampere hour battery, consisting of 8 elements, 33 or 32 140 elements, so 8 of these in configuration that's called 4S2P. But I'm going to need another configuration of these ones. I'm going to need 12S. So that's gonna be a 36 volt battery, 15 ampere hour, 36 volt battery of 12S configuration, 12 serially connected, 33 140 elements. So which is sort of kinda like a lot, but again, this is 8, 12, that's just 4 more. And to make it like slim enough, I'll probably just do it. Let me show it to you. To make it more flat, I'll do it like this. So this is gonna be probably the battery I'm talking about. Losers, thank you very much for jumping in. Yeah, I'm actually wrapping up things here, so that's gonna be another battery holder that I'm going to design. But before actually committing to anything here, I'd like to see how this design, with its pretty thin walls here, how this one turns out. So but yeah, this one's going to be kinda a little bit simpler, less constraints on the size. But it will have to accommodate for a couple of other things here. So that I would want to actually sort of kinda have in there. But this is gonna be the next design. What I will have to think about, the enclosure. So this is just the holder. What if I could build an enclosure around this one? So that would be way more fun to have an enclosure, and that would probably be required because this one's going to be for a bicycle. So, but again, first I gotta print these two to take a look at how they actually hold the batteries, because some walls here, they are like super thin, which is not a problem for this one, even if they are like paper thin, but might be a problem for this one. And this design here, it's a little bit too generous on the wall thickness, so maybe something a little bit in the middle between this one with very thin walls and this one. Actually, let's compare. I'm kinda curious what's the difference in size here. So you go away. Difference in wall thicknesses here. So what if we turn you 60 degrees? Yeah, to be able to align the walls here, these diagonal walls, to our vertical lines. So it is around 2.5 millimeters, which is very solid. So 2.5 millimeters between these ones, and let's compare to these ones. Please, I would just want to take things and move them around. $60, please. And drop down. Where are you? What is wrong with you? That's 20. And it doesn't want to be aligned. Okay, drop on the plane. And drop under the plane. It's not showing it properly for some reason. Oh, I can see the grid on top of this color. I can see the grid on top of this color. 20. But here it's not showing me the grid. Why? Okay, this way it is showing me the grid. So, and here we have, here it's a little bit less than millimeter. I think it's like 0.8, 0.7 of a millimeter of thickness. And actually these walls here, they are, well, 0.4 maybe, which is not a lot. Which is not a lot at all. Okay, so remove this. Whew! It took us quite some time, but we got this design done. So, as I said, this thickness is a little bit too generous, more than 2 millimeters. And this thickness for a bicycle, it's maybe a little bit too small. Yeah, and we got to have them all snug in there without ability to hit each other, because actually I learned it from like watching videos and whatnot. So batteries being next to each other like this and doing like this or like this, constantly hitting each other a little bit, just rattling or just rubbing off of each other, that might end up in the walls just getting destroyed and the walls getting penetrated sooner or later, and well, the batteries getting destroyed, getting shorted and whatnot. So turns out you gotta take care of not allowing them to, well, rub and rattle off of each other. So, which is, yeah, something to know. And these ones, they're actually pretty heavy, and the accelerations that they might experience while just cycling around, they might be enough to just them to hit each other hard enough, not just to rattle, but pretty much to hit each other, even if there is not a lot of room for them to acquire any momentum. but then again, the shocks would do that to them, like boom, 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 and you'd be done. The thing about these elements, these are like lithium, iron, polymer elements, is that they're supposed to work for way more recharging cycles. So, and I like this idea. So pretty much the amount of cycles is so serious that they're gonna last for as long as we probably maybe even longer. So for 20, maybe my calculations that it would be like for 20 years. No, wait. 15, maybe 20. So something like that. In case of no, more than 20, 30 maybe. In case of lightly used electrical bicycle, that's used only when during like the dry months, summer months pretty much. Winter, not winter, a little bit early late spring, summer, and early autumn. So yeah, but these ones, these holders, they are for a different assembly, and this is more like my test bed to learn how to make these things. So these are not needed. These are just an experiment in learning and designing stuff. So thank you very much for watching, everybody. I'm going to call it a day here, though there is quite some things to design still. I needed to design something else. I remember that, but I don't remember what actually I wanted to design. So thank you for watching. Yeah, I'm going to send these ones to the guy who prints them for me, and I'm going to ask him to print it faster, as fast as possible, because usually he takes quite some time. So, and maybe I'll post it on Twitter when there's something to post, how they fit and whatnot. YouTube people, thank you very much for watching on YouTube. I actually didn't see, I don't even know if I had any viewers, but in case of these streams, viewers actually come later. So thank you very much for watching on YouTube. If you watch this as a doesn't matter if you watch this as a recorded video, as a live stream, please leave a like if you like this one. Again, follow me not just on YouTube, subscribe to me not just on YouTube, but follow me on Twitter to maybe see the results. On the other side, the results are going to be definitely discussed here, because I'm going to assemble the battery. I'm going to weld the battery using these holders on stream too. So as for my Twitch viewers, the same, pretty much the same to you. Thank you very much for watching me on Twitch. Quite some lurkers tonight. And not lurkers, so Zwof, Chorchy, Nicola, Space Maldilab, and Losers, thank you for jumping in, and Tex, the new follower, thank you for jumping in. So, and now, as we always do, let's find somebody to raid on Twitch. So that's probably going to be my stream for, so this is my Saturday stream. And I usually don't stream a lot on Saturdays, but something different happened today, so nice. So let's see who we can read. Let me check a science and technology section of Twitch, because I really rarely go there. But there's a lot of, like 90% of streams in science and technology. It's like automated, unfortunately. So can we have somebody not automated? There's a person doing cat in on shape. That's another pretty serious, very serious platform for cat. So yeah, that's not the first time I see people using on shape. Maybe one day I'll be using it too, but maybe it's going to be something else. Oh, I cannot read this guy. He has followers only chat. That's not good. I found one 3D modeler, found one CAD user, and they are unfortunately not letting other people in pretty much. Yeah, bad. Okay, then we are going back to, I think, our homeland. And our homeland is Daisy. If you give me a second, I'll find somebody to read. Just a second. There's a person I haven't seen online in a very long time, but maybe because we are active at different times. So let's go and say hi to or maybe I'm just completely confusing them. Let's go and say hi to Big New F or One or Big New. The link's in my Twitch chat. We are going back to our motherland, fatherland, DZ section of Twitch, and I will see you all, well, probably tomorrow. That's it for tonight, for this day. Goodbye and good night. And I'm glad that we actually figured out this design. Yeah. Cheers.